We believe that when the universe began in a Big Bang, there was an equal amount of matter and antimatter created. But if we look at the universe today, we see very little amount of antimatter in any observable universe. So one of the big mysteries in modern science is what happened to antimatter in the universe. Antimatter is a counterpart of matter, and for every matter particle, there's antimatter particles. We work in the ALPHA project, which is an international project located at CERN, which is an international laboratory in Geneva, Switzerland. And at CERN, we study what is called antimatter atoms. And by studying these antimatter atoms, producing them and trapping them in a laboratory, we want to see if there's any difference in its fundamental properties, such as do they shine a different color, do they weight differently between the matter and antimatter. According to the fundamental laws of physics, which connects the quantum physics and Einstein's relativity, these properties of antimatter and matter has to be exactly the same. So the ALPHA project is an international project. So the groups from different countries make different contributions depending on their expertise. From Canada, we have several expertise that are unique within ALPHA. And one is a detector, a particle detector. So here at TRIUMF, we design and also build electronics for particle detectors. And in order to study antimatter particles, we have to be able to detect it. And so we have constructed a sophisticated electronics here at the TRIUMF laboratory, and then brought it to CERN. CERN laboratory is the only place in the world which can produce antimatter particles right now. So that's why we go there from Canada to participate in this international project. One of the recent results that ALPHA have been able to achieve is to study the internal structure of antimatter atoms for the first time. Nobody has seen what the internal structure is of antimatter atoms. And using the microwave techniques developed here in Vancouver, both by Professor Hardy and Professor Hayden of UBC and SFU, we've been able to demonstrate the first microwave spectroscopy experiment on the antimatter atoms. Without NSERC support, we couldn't have done any of this research.